During the past year, our team has focused on the impediments, both technical and socio-political, to the implementation of the space solar power concept. While transmission and reception hardware and prospective uses are both commonly discussed, they are not, by far, the only area where innovation is required.
We asked the question, what would it take for a space solar power system to be deployed? We identified multiple areas of focus in response to this question. We looked at the benefits of using higher frequency transmission, as well as system reliability issues, including cybersecurity needs.
We've also looked at what is perhaps the most pronounced question, and that is, how do we convince people that this technology is safe to use? For that, we proposed its demonstration to both support and enhance a manned mission to Mars as a part of a 4-stage implementation plan.
In Stage 1, we will test the technology in low Earth orbit using small spacecraft. This has been discussed extensively in prior work. Our testing will focus on the higher frequency levels proposed by Commonwealth. This testing will provide us with the opportunity to use our patent-pending transmission assurance technology, which ensures that power is transmitted to the designated reception point and only to this point by preventing accidental or malicious beam redirection. An extended testing period will be required to generate the space heritage and qualification needed for the technology to support a manned mission. In Stage 2, we plan to test the technology on Mars. Space solar power on Mars solves many of the issues commonly asserted for its use on Earth. One issue noted by former NASA Administrator Michael Griffin was the cost of getting the solar power spacecraft into orbit. In the context of Mars, you have to launch it anyway. You're actually saving propellant and thus money, and reducing risk by not having to perform entry, descent, and landing for the power generation equipment. The power receiving station can be placed at a safe distance from the planet's only inhabitants, the astronaut team, and mobile reception can be used in support of exploration and experimentation. With the technology demonstrated safely on Mars, it's time to bring it back to Earth. However, you have a chicken or egg problem in this regard. You need to have a large base of users to support the cost of deploying a geosynchronous power generation and transmission station. Instead, in Stage 3, we'll take a page out of the communications satellite playbook and use a bent pipe transmission technique. Finally, in Stage 4, with a large base of customers with power reception equipment already installed, the orbital power generation and transmission spacecraft can be launched, providing power to the existing ground stations. On Earth, this technology can be used to provide power to remote parts of the world for humanitarian, scientific, and defense applications. It can also be used to supply augmentative, or in the longer term, potentially primary power to the terrestrial power grid. While the applications of space solar power and microwave power transfer for planetary exploration are undoubtedly numerous, the benefits that can be provided on Earth are astounding. This prospective clean and reliable technology that can provide power on demand to virtually anywhere on the surface of the Earth can energize entrepreneurship in areas far removed from electrical utilities. Once before, the United States government undertook such a grand energy challenge. In 1963, President John F. Kennedy, perhaps best remembered in the space community for challenging the nation to go to the moon.
We choose to go to the moon in this decade and do the other things. Not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills. Because that challenge is one that we're willing to accept, one we are unwilling to postpone, and one we intend to win, and the others too.
Championed a federal program to provide power to remote areas of the United States. In that same year, at the University of North Dakota, he stated,
"This state had, 30 years ago, 3 out of every 100 farms lit by electricity, and now nearly all are. What was 30 years ago a life of affluence, in a sense today is a life of poverty."
Unlike in 1963, we need not run expensive power lines across the country. These same benefits can be provided through wireless power transmission and local receivers to those that remain worldwide without power. The road to space solar power is undoubtedly a long one. The capital required is significant, the technical advances required are well beyond trivial. But we must take the long view advocated by Kennedy.
Marshal Lyautey, who was the great French marshal in North Africa, was once talking to his gardener, and he suggested that he plant a tree. And the gardener said, well, why plant it? It won't flower for 100 years. And Marshal Lyautey said, in that case, plant it this afternoon. I think that's good advice for all of us.
Kennedy's venture to the moon brought back advances in roofing, footwear, and firefighting, among many others. We suggest that to bring the benefits of space solar power to Earth, the first stop is Mars.